I call the function 1 by sending 1. Now you can see it is displayed as 65432 1. 65432 1. I said here less than. Now you can see 54321. What is output is displayed 54321. So the output is 54321 is the output. So this is called as a recursive function call. Recursive function call. This is called as recursive function call. So what will happen in function recursion is, so this is what will happen in function recursion. So assume that this is a function stack, function execution stack. Okay, this is a function execution stack. So whenever function is called, it is pushed inside the stack. And after execution of function, it is popped from the stack. Okay, I'll try to make this as a 3 here. Okay, so it is displayed what here 3 to 1. So here my program execution is started from executing. This is one executable statement. And this executable statement is invoked first. So it means there is a memory allocated for there is a memory allocated for which function now? Main function. So there is a memory allocated for which function? Main. So main function is pushed inside the stack. And main function is calling which function here? Function 1. And it is called function 1 by sending the value called 1. So whenever function is called, the memory is allocated for that function. So there is a memory allocated for which function here? Function 1. And what is the value of n in function 1 here? 1. And here it will check the condition. Is it 1 is less than 3? Yes. Then again it is calling function 1 by sending which value here? N plus 1 value. So in this case, which one is the calling function here? Function 1. And called function is also same. So what will happen? Function 1 calls again function 1. So there is a memory allocated for function 1. And in this function 1, what is the value of n? 2. Then after that, is it 2 is less than 3? Yes. Again, it will call the function 1. So again, it will call the function 1. Okay, function 1 is called. And in this, the value of n is what here? 3. Is it 3 is less than 3? No, condition is a false. When the condition is a false, it will print which value? N value. What is the n value in this function? In this function call, what is the value of n? 3. So is it execution of this call is over or not? Yes. Once it is over, it returns to calling function. So in this calling function, what is the value of n? 2. Is it execution of this function is over? Yes. Then return to calling function. And what is the value of n in this calling function? 1. And is it execution of this function is completed? Yes. Then return to which function? Main function. Return to main function. Is it execution of main function is over? Yes. Return to the calling place. Is it execution of this is completed? Yes. It is any more statements to execute? No. It will stop. It means whenever function is called for that function, whenever function is called for that function, memory is allocated. Whenever function is called for that function, memory is allocated. Whenever function is called for that function, memory is allocated. And once the execution of function is completed, memory is deallocated and returned to which function? Calling function. So there is a lot of problems which can be solved by using which one? Recursion. The best example is like factorial is it. For example, So the output is 3 to 1. Suppose, so write a function to find factorial of input number. Write a function to find factorial of input number. I want to write a function, but this finding I want to do it by using which approach? Recursive approach. I want to do this by using recursion. I want to do this by using which one here? Recursion. Okay, so here, suppose I'm writing a function called factorial. Factorial is a function which receive number. Factorial is a function which receive what? Number. Suppose if number is 0, if number is 0, what is a factorial? 1. N factorial is what here? 1. 0 factorial is what? 1. Okay, else I have to say return. So n into factorial n minus 1. Okay, I said here n into factorial n minus 1. Return n into factorial n minus 1. N into 4 into factorial of 4 minus 1 is 3. That is 4 into 3 into 2 into 1. Okay. So this is factorial, but that is using recursion here. So first I have to read a number. So what I'm doing is I'm trying to input one number. So number equal to integer of input. Enter any number. Enter any number. So I try to input one number, right? Enter any number. And for this number, I have to find out the factorial. I'm saying result. Result equal to factorial. Result equal to factorial by sending number. Then after that, I have to print factorial of this. So format. So factorial of number is factorial of number. So number is. So this is called as which one here? Result. Then I call the function main here. I call the function main. Okay, so once I run this, I enter the number 0. 0 factorial is what here? 1. Okay, so I try to execute some 3. 3 factorial is what here? 6. Okay, 3 factorial is 6. I enter the number some 5. 5 factorial is what here? 120. So factorial of number 5 is what here? 120. Okay, so you're trying to find. So the factorial for the input numbers. Okay, you are trying to find the factorial for input numbers. But how it is? Let us see how this program works here. So if you see this program, suppose assume that this is an execution stack. Okay, this is an execution stack. Okay, stack data structure uses last in, first out. This is an execution stack and this stack follows last in, first out. So what you're trying to do is you're trying to input the number first. What you're trying to do is you're trying to input the number first. So what is the number I'm trying to input here is 3. What is the value of number here? 3. Okay, so the number is 3. So it means now my program execution start from main. This is an executable statement. So which function is called here? Main function. So there is a memory. There is a memory allocated for which function here? Main function. Okay, there is a memory allocated for which function here? Main function. Now inside the main function, you are reading the value of number. So what is the value of number I have given? Suppose the value of number is 3. Okay, so the value of number is what here? 3. The value of number is a 3. This is number 1. Then I want to find the factorial for this. So I call the function factorial. So factorial function is called by sending the value called number. So what is the value of number is sent here? 3. So what will happen? There is a memory allocated for factorial. So memory is allocated for which function here? Factorial function. So there is a memory allocated for factorial. And within this, there is a memory allocated for n. What is the value of n here? 3. Is it n value is 0? No, n value is not 0. Then what will happen? It will go to else and say return n in 2. Return n in 2. So it is trying to return. It is trying to return. What it is trying to return in this function, n is nothing but what here? 3 into. Okay, 3 into, again it is calling which function? Factorial function by sending n minus 1 value. Again it is calling factorial function by sending n minus 1 value. So what will happen? It will call again factorial function by sending which value? N minus 1 value. So what is a calling function here? Factorial is a calling function which is again calling the same function. And what is that function? It is calling factorial only. Again it is calling same function. What is that function? It is calling factorial by sending n minus 1 value, where n minus 1 means the value of n becomes what here? 2. So again it will check the condition. Is it n equal to 0? No. Then else return. Return what it is returning. In this function call, it is what? 2 into. Okay, 2 into what is that? Factorial n minus 1. It means again it is calling function factorial by sending which value? 1. Again it is calling it by sending factorial 1. Yes. Then again there is a memory allocated for factorial. There is a memory allocated for which one? Factorial. So where the value of n will be, where the value of n will be what? 1. Where the value of n, what is the value of n here? 1. And it will verify, is it value of n is 0? No. Then return again, return. So what it is returning? 1 into factorial n minus 1. Factorial n minus 1 again. Factorial n minus 1 means what here? 0. So it is calling again factorial function. Again factorial function is called. And in this factorial function, what is the value of n? 0. In this factorial function, what is the value of n here? 0. The value of n is 0. If n equal to 0, now is it 0 equal to 0? Yes. Then who called this factorial function? This factorial function. So if the value of n is 0, it is returning which value? 1. But where it is returning n 1 at this place. Now who is the caller of this factorial? This factorial. So this factorial is returning 1 to this factorial function. So that is nothing but 1 into 1. 1 into 1 is returned to which function? This factorial function. And this is nothing but 2 into 1. And 2 into 1, it becomes what here? 2. And this value is returned to this factorial function. And 3 into 2 is what here? 6. And this 6 value is written toward main function. And what is the result of this here? 6. So here, this is a calling function and this is a called function. And calling function and called function. Calling function and called function. Calling function and what here? Called function. After execution of called function, it returns to which function? Calling function. So this factorial is returning 1 to this calling function, and 1 into 1 result is returned to this calling function, and 1 into 2 is returned to this calling function, and 3 into 2, this value is returned to which function? Main. So your return is there. But is it values returned or not returned? Not returned, because 2 into, again it is called which function? Factorial. Once that value is written, now the result of this is returned to which function? Calling function. So this is how the evaluation of recursion is done. This is how evaluation of recursion is done, by using which approach here? Stack. Now stack uses last in, first out. So internally function recursion internally function recursion uses the data structure called stack for evaluation of, internally it uses data structure called stack for evaluation of, internally it uses the data structure called stack for evaluation of these things, right? Okay. Then next we'll talk about, so all these functions and everything you're trying to put inside one module. So next what we are talking about is modules and packages. But before modules and packages, there is one more thing is there. That is nothing but monkey patching. What is this? Monkey patching in functions. Actually, you learn this monkey patching in modules also. But anyway, modules or functions, anything is the same, monkey patching. So most of the scripting languages support this monkey patching. Patch is nothing but replacing or rectifying. Okay, patch is nothing but replacing, or what is that? Rectifying it. So that is called as which one? Patch. You have a function, you already develop one function, and that function is not working properly. Then what do you do it? Patch it. Patch it with what? Another function. You patch with what here? Another function. Another function without doing any changes into what? Existing function. Okay, that you call it as which one? Monkey patching. Monkey patching. So most of the scripting languages supported this monkey patching, right? Most of the scripting languages supported this monkey patching. You can see monkey patching, Python, monkey patching what? Ruby, monkey patching in what? JavaScript, monkey patching in Go language. Okay, Ruby, Python, JavaScript. Okay, so but this is monkey patching in what? Python. So yeah, this is monkey and this is a patch, right? Okay, so patching, monkey patching, right? Simple definition. So a monkey patch is a way for a program to extend or modify supporting system software locally. Okay, locally. If you want to update a function locally, you can update it by using which one? Monkey patch or monkey patching. In Python, the term monkey patch refers to dynamic modification of a class or module, anything. In Python, we can actually change the behavior of code at runtime. We use the module monk as below code change the behavior of function runtime, assigning different things, right? So that is done by using which one here? Monkey patching. This is one definition. A lot of definitions are there. So here there is one, so Python dynamic scripting language. Not only does it have dynamic type system where a variables can be assigned to one type first and change it to what another type, but its object model is also dynamic. This allows to modify its behavior at what runtime. So this is possible using monkey patching. This is an idea that we can modify the base layer of program without modifying the high level code. Imagine you can use a print function to print something to the screen, and we can modify the definition of this function to print it to a file without modifying any single line of your code. So it is possible because Python is interpreted language, so we can make changes while the program is running, and we can make use of property in Python to modify. Yes. This is one definition of monkey patching, but we'll have a simple definition. So monkey patching. See, it is not only related with it is not only related with the class and modules. So what module contain is functions. So what module contain functions here? So monkey patching is a dynamic technique in Python by which you can modify the behavior of existing class or module, or what is that function, anything you can say. And to change the behavior of a class or module, you don't need to change the code inside the class or what method. So that can be done by using which one? Monkey patching, right? Okay, yes. So for example, say simple, it is very simple concept. So locally you can able to do changes without, but this will be repeated again in modules and classes also. This will be repeated again in modules and classes also. This will be repeated again in modules and classes also, right? This will be repeated again in modules and classes. Okay, for example, there is a function one, right? A simple example, I'm writing it here. Now this is inside function one. What is this function here inside function one? So this is a function one, and this is which one here? Patch. So you are trying to put a patch on function one, right? By adding some new features. Okay, I can call within this patch, I'm saying this is what do you call it as monkey. What is that here? Patching. So two functions are there. So I call the function one. I call the function one. What I did here is I call the function one. I call the function one here. So what will happen? It calls the function one. What is the message inside function one? But I want to change this function one. I want to change this function one functionality by putting one patch. Okay. Then what I'm doing is I'm writing here function one equal to which one here? Patch. If I'm writing function one equal to patch, now this function one is assigned which function here? Patch function. Miss, is it this function one is called patch function or function one patch function? Okay, this function one is assigned patch function or function one patch function. Now this is monkey patching. This is which function here? Monkey patching, because I said function one equal to patch. So I don't want to modify the existing. See, this is inside function one. Okay, I call the function one, or it will call the function one, but I want to patch it. I want to patch. This function one should be patched. Then I'm trying to say function one equal to which one? Patch. So which function is called here? Patched function or not? Yes. Okay, it is called which function here? Patch function. Now this is a patch. So this you can call it as monkey patching. Monkey patching. This is called as a monkey patching here. This is called as a monkey patching. Like, for example, print function is there. What is this function here? Print function. And print function is trying to print this value. Actually, where print function will print the values on monitor, on console or monitor. But I want to print inside a file. I want to print inside what? File. Then what I'm doing is I'm trying to say definition. This is patch one. So what is this here? Patch one. This will receive a message. This will receive a message. This will receive what? Message. And where it will print inside one file. So here I try to create one file. So open, and I try to create a file in. I try to create one file, file one. I try to open this file in write mode. I try to open this file in what? Write mode. Already I said print in the beginning, how to print inside a file. Okay. Then after that, I'm saying print. What I'm trying to print here? Message. I try to print a message inside which one? File. What is the name of the file here? F. And I try to close the file. I try to close the file. So what I'm doing now, print function, by default, it prints on what? Console. But I want to print in what? File. Then I try to give the patch. Print equal to, which one here? Patch one. Print equal to patch one. What I said here, print equal to patch one. So what this print will do, is it this print will print on a console or inside a file? Inside a file. If I run this, where is the output? The output is not on the console. The output is inside what? File. Where this file is created in current folder. And this is my current folder. And what is the name of the file? File one. Okay. So this is the name of the file. And just try to open this file with a notepad. And you can see the message what here? Hello. But are you modified print function? No. You have not modified print function. You have not modified print function, but you have just given patch to which function? Print function. So dynamically, you're changing the behavior of what function locally. Now this changes is only locally, right? Only for this main function, but not for other functions. The other function print is what here? Same. But for main function, what is the printer? Is it printing on a console or printing on a file? Printing in the file. Why? Because I try to assign one patch. So what is a patch? Now this is a patch which is not trying to print on a console, but it is trying to print inside what? File. So that behavior, you are saying it as what here? Monkey patching. So you can change the behavior locally, right? Okay. So this can be done with the functions, modules, classes. Okay. Dynamically, you can change the behavior of a class also. Dynamically, you can change the behavior of class also by using which one here? Monkey patching, right? But in this case, this print hello. Hello will not be printed inside a console, but hello will be printed inside what? File. Hello will not be printed inside a console, but it is printed on a file. So this is how you do the patching by changing the behavior. This is how you do the patching by changing what? Behavior. So that is called as which one here? Monkey patching here. Next one is modules and packages. Modules and packages. So what is a module and what is a packages? You must know what is a module and what is a package. So Python is a multi-paradigm programming language. Python is what your multi-paradigm programming language. Python is a multi-paradigm programming language. So when you're saying it is multi-paradigm, it will support different programming approaches. And one of the thing is modular programming. Okay, so what is module in Python? So Python is multi-paradigm. Python is multi-paradigm programming language. Python is multi-paradigm programming language. It allows to write programs using different programming approaches. So one is it allows to write. Okay, one is which is called a procedural oriented programming, which is called as POP. Modular oriented programming, which is called as what? MOP. And there's one more which is called as object oriented programming, which is called as OOP. So Python is multi-paradigm programming language. Now, till now, in the beginning, we worked with unstructured. So after that, we worked with procedural. So what will happen in procedural programming? In procedural oriented programming, till now what we did? In procedural oriented programming, you're trying to organize the code by dividing a programming instructions into a small pieces. And what these small pieces are called here? Functions. It means your program is divided. Your program is divided into a number of functions. Your program, you're trying to organize instructions, you are by dividing into a number of functions. And this you call it as which programming? Procedural. So there is a function 1, there is a function 2, and there is a function 3. There is a function 1, function 2, and what is that? Function 3. Okay. So this kind of programming is called which one? Procedural. In procedural, there will be a reusability of functions within the same program. Reusability of functions will be in the same program. But when it comes to the modular, you try to divide. You never develop a project by writing everything inside one function or one program. Sorry, you never write or you never develop application by writing everything inside one program. But rather than you try to divide your application into what? Number of programs. You try to divide your application into what? Number of programs. And in Python, each program is called one module. In Python, each program is called as one module. So that is what we have seen in the beginning. If you don't remember, you just refer it. Okay. Every program is called as one module. And this module is divided into number of functions. This module is divided into a number of functions. Each module is one program, and each module is divided into a number of functions. So this is how you develop it. So a project is not one program. A project is a collection of programs. A project is a collection of programs. Now assume that this is function 1. Okay, assume that this is a function 2. Okay, assume that this is a function, this is function 3. Okay, assume that this is a function 4, like this. You are trying to divide your application functionality into number of programs rather than writing in one program. So that maintaining your code becomes very easy. So that your maintaining code becomes what here? Easy. Maintaining the code becomes very easy. Now this is function 9 and this is function 10. And you may use the content of one module inside another module. You may use the content of module 1 inside module 2. And you may use the content of module 2 inside what? Module 1. You may use the content of this module 3 in module 1. Or you may use the content of module 1 inside what? Module 3. You may use the content of module 2 inside a module 3. Or module 3 inside what? Module 2. So there will be a reusability between what? Programs. Now this approach you call it as which one? Modular. This is called as which one here? Modular oriented programming. In modular oriented programming, okay, so the application is divided into a number of programs. In modular oriented programming, so in procedural oriented programming, a program is divided into a number of functions. In modular oriented programming, application is divided into number of programs. In modular oriented programming, an application is divided into number of programs, and this number of programs are called what here? Modules. Okay, number of programs, and each program contains what is that? Number of what? Functions. Number of function, and this allows reusability. This allows reusability between what? Modules, or what is that? Programs. This allows reusability between the modules and what? Programs. So in Python, each module is, or each program is called one module. Each Python program or each program is called one module. Or you can say each Python program is one module, and module is saved with extension. Module is saved with extension .py. So each Python program is called as one module. Okay. Now till now we have written so many programs. All these are called modules or not? Yes. Every Python program is one module. Okay. In Python, each program is called one module, and module is saved with the extension .py. So these modules are two types. One is user-defined modules. And second one is predefined modules. And these predefined modules are called, which one? Libraries. These predefined modules are called libraries. So the modules provided by Python are called predefined modules. Example is like you have a sys module, you have OS module, date time module. Okay, date time module, random module. Okay, sys module, OS module, date time module, random module, copy module. Okay, like this. There is a number of modules, and these modules are called which modules here? Predefined modules. These are called which modules? Predefined modules, that is existing modules, like math module. Yes, math is a module, copy module. So many modules are there. Now C math module. All these are user defined modules are predefined. So apart from this, you can build your own modules. I mean, writing your own programs with some functions that you can call it as which modules? User defined modules. So that you can call it as which modules here? User defined modules. Okay, that is called as user defined modules. So the modules developed by so the modules developed by so modules developed by programmer. The modules developed by programmer are called user defined modules. Okay, but any module is user defined only. If somebody is developed, the developer, it is user defined. For us, it is what? Predefined. Suppose you develop a module, for you it is what? User defined, and for me it is what? Predefined, right? So all the modules are user defined only. But if somebody is developed and you're using it, then it's called predefined. Okay, and if you're developing it and you're using it, then it is what? User defined. Application related. It is what here? Application related. But module is nothing but a Python program. So this allows reusability between the programs. This allows reusability between the programs. You can use the content of one program inside what? Another program. You can use the content of one program inside another program. Is you can use the content of one module inside what? Another module. So module is nothing but a program here. Module is nothing but program, right? Okay, then so how you develop a module is nothing but writing program only. Module is nothing but writing one program. For example, I write one module. Suppose this is module or Python program. Okay, this is one Python program. Some calc module. Module is nothing but program only. So within this calc module, I'm writing all the functions belongs to calculator. There is a function called which one? Add. So add function receive two values. Add function receive two values and return what here? Addition. There is a function called sub having two values and then return a minus b. And there is a function called which one here? Multiply. Receive a comma b and return what? A into b. And there is a function called division a comma b and return a divided by b. So what this calc.py is having only the functions belongs to calculator. Calc function is having all calculator related functions, but it is not calculator. It is having only the functions of which one? Calculate. So this is my calculator. This is my calculator, calculator.py. Now calculator, this is my calculator. So within calculator, what calculator will do? It will do addition, subtraction, multiplication, and what? Division. But is it functions of calculator are there inside calculator? No. The functions of calculator is not there inside what? Calculator. It is available in which module? Calc module or calc program. Then what I have to do? I have to import this. I have to import this calc module by saying import. What is this? Calc. So it means you are importing this calc module inside what? Calculator. You are importing this calc module inside what? Calculator and do operations. Then do the operations. Now you want to add it. You want to add it now. Result 1 equal to calc dot. Which one? Add. Calc dot add. What is the calc here? Name of the module. What is add here? Name of the function. What is a calc? Name of the module. What is the add here? Name of the function. I said 5 comma 4. Result 2 equal to calc dot. What is the name of the function? Sub. Where I'm saying 5 comma 2. Then result 3 equal to calc. And I'm trying to say multiply. I just write here some 4 comma 5. Result 4 equal to division. Calc dot division. Where I'm saying 2 comma 4 comma 2. And then I try to print what I'm printing. Result 1, result 2, result 3. Result 3 and one more is what? Result 4. But where is the functions of calculator? Is it functions of calculator inside the calculator or outside? Outside. Suppose you want to add some more functions in calculator. Will you add those functions in calculator or inside the calc? Inside the calc. If any changes are there in calc functions, will you do changes in calculator or inside calc? Inside calc. Without doing any changes in what? Calculator. So maintaining your code also becomes what? Easy. Now this is which module? Reusable module. This is reusable module. I cannot execute this module. I cannot execute this module because there is no executable statements. Is it this module is having any executable statements? No, there is no executable statements. You have only functions definitions. I cannot run this calc program, but I can run this calculator program because this is which statement? This is which statement here? Executable statement. This is executable statement. Executable statement. So writing function is not executing function, right? To execute the function, I need to call the function as an executable statement, and this is invoking the function or executing the function. Means my program execution starts from here by invoking which statements here? Executable statements. By invoking which statements here? Executable statements. Invoking executable statements. Now this is called as which module now? Executable module. So what is executable module? The module or program which is having which statements? Executable statement is called as executable module. The module or program which doesn't have any executable statements, and that you call it as which module? Reusable module. So you are using the functions of this calc inside which module? Calculator module. But how you are using it? You are using one statement called which one? Import. You are trying to use one statement called which one? Import. Import is there. Okay. Yes. Just try to understand. This is how you are trying to develop application by dividing into a number of modules or programs, because you never develop a project by writing all the functions in one program. Program you try to divide into what? Number of programs, and each program is called as one. You try to divide into a number of programs, and each program is called one module. Each program is called as one module. Remember this, each program is called as one module, and then use the content of one module inside what here? Another module. Use the content of one module inside another one. So how can I use one module inside another module? by using one statement called what? Import statement. Okay. So import statement. So you're trying to use with what statement? Import statement. Import is there. Import is a keyword. Import. So import keyword is used, okay, to import or to use one module inside what? Another module. If you want to use one module or program inside another program, you are trying to use which keyword here? Import keyword. And you have a multiple syntaxes of import keyword. And this is a syntax one. Import. What is this here? Module name. And there is a syntax two. You are trying to say import. What you are writing? Import module name as which name? Alias name. Import module name alias name. And syntax three is from module name import identifiers. Okay. And syntax four is from module name import, so identifier as alias name. Okay, so this is multiple syntaxes. So there are four syntaxes you have, or even syntax 5. You can write from module name import, from module name import. What is that? Star. So these are multiple syntaxes of using this import statement or import keyword. Import keyword is used to import or use one module inside what? Another module. Import keyword is used to import or use. Import keyword is for importing or using the content of one module inside what? Another module. Okay, to use the content of one module inside what? Another module. Okay, right now these are different syntaxes are there. 5 syntaxes are there. Syntax 1, syntax 2, and syntax 3, syntax 4, and one more is a syntax 5. So import keyword is used to import or use one module inside what? Another module, or referring referring functions, variables, and classes of one module inside what here? Another module. So import is having multiple syntaxes. So these are different syntaxes of which statement here? Import statement. So there is a syntax one is there. What is the syntax one? Is import module name So this allows to refer the content of another module inside current module with what is that module name, inside current module with what here module name. For example, if I am saying import, for example, if I am saying import, how you refer the content of module 1? You refer the content of module 1 is like this. For example, suppose two modules are there. So this is a module 1 and this is what here module 2. Two modules are there. This module is module 1 and this module is module 2. It's nothing but module 1.py and this is module 2.py. Two modules are there. So in this module, there is a variables. So these are called global variables. These are global. What these are called global variables. Global variables. These are called as global variables. And in this module, you also have some functions. So there is a function 1. So function 1 of module 1. There is one more function, that is function 2 of which one here module 1. Function 2 of module 1. Now I want to use this variables and functions of this module 1 inside what? Module 2. First what you are doing, import. First you are writing import module 1, and after importing, how can I use it? I can use it by saying print. Now what I want to use is, I want to call x variable module 1.x and print. I can write here module 1 dot, what is that? Y, and I can call module 1 dot, what is this? Function 1. I can call module 1 dot, what is this here? Function 2. But how you are referring the content of the module with what name? How you are referring the content of the module with what name? Module name. You are saying module 1 dot y. You are saying module 1 dot, what is this? Function 1. You are saying module 1 dot, what is that here? Function 2. Module 1 dot function 1 and module 1 dot function 2, right? Just try to see here. So I try to develop one module. So x equal to 100 and y equal to what? 200. And function 1. Now function 1 of module 1. Function 1 of module 1. And there is a function 2. And this is function 2 of module 1. So function 1 of module 1. And this is module 1 dot. I'm writing module 1 dot py. Okay. Then I write one more module. So go to file and write another one. So where I'm trying to import, what I'm importing here, module 1, and here I can call this. I can write again one more function main, and here I can say print module 1 dot, what is that? X, and print module 1 dot y, and module 1 dot, I can call the function 1, and I can say module 1 dot, what is that here? Function 2. Module 2, what is this module here? Module 2. So I try to, now this is executable statement. I try to run the module 2. Now what is x value? 100. What is y value? 200. And this is a function 1 of module 1 and function 2 of what? Module 1. Anyways, I try to use the content of module 1. I try to use the content of module 1. This content of module 1, I try to use inside what? Module 2. But how I used here? By using which statement? import statement. How I use the content of one module inside another module by using which statement? Okay, by using which statement? Import statement. By using which statements? Import statement. Suppose there is another module called module 3. So this module 3 is having function 4. This is a function 4 of module 3. Okay, there is one more function is there here, function 5. And this is a function 5. Function 5 of module 3. Okay, so this is module 3. So there is a module 1, module 2, and module 3. And within module 1, within module 2, I want to use module 1 and module 3. Then can I write here comma? I try to import how many modules here? 2 modules. That is module 1 and module 3. And from module 3, I'm calling which one? From module 3, I'm calling which one here? Function 4. From module 3, I'm calling which function? Function 4. From module 3, I'm calling which function again? Function 4. From module 3, I'm invoking function 4. From module 3 again, I'm invoking which one? Function 4. I just run this. Now function 1 of module 1 and function 4 of module 3 and what? Module 3. So we can import multiple modules. You can import multiple modules by using import. So import keyword here, import keyword allows to import multiple modules, okay, by separating with what here, comma. You can import multiple modules by separating with the comma import. So you can import either single module or you can import what? Multiple modules by separating with this comma, right? Import one module or multiple modules. Or you can write import module name, import module name, import module name. Instead of writing multiple import statements, you can write one import statement to import what? Multiple modules. You can write one import statement to import multiple modules. So here I have 3 modules. So that is module 1.py, module 3.py, and module 2.py. So in module 1.py, I write some variables and functions. In module 3.py, this is module 2.py. So in module 2.py, this is main program. And there is a module 3.py where I've written how many functions? 2 functions. So what I'm doing, I'm trying to use import module 1 comma module 3. So how many modules I'm importing in module 2? 2 modules. That is module 1 and module 3. I try to import 2 modules, that is module 1 and module 3. I try to import 2 modules, that is module 1 and module 3. Inside which module? Module 2. But for that, you are trying to use this particular syntax. So you also have import module name as an alias name. You have a syntax of module name with the alias name. Now this is reusing. How many modules inside this module? module to more than one module. So for that I said import module name comma module name. So I try to import how many modules here? Two modules, that is module 1 and module 3. So there is a syntax 2. There is a syntax 2 is there. What is the syntax 2 is import module name as a import module name as which name here? Alias name. Import module name as an alias name. Alias is nothing but, is it alias name is an alternative name or not? Yes. So import module name as an alias name. So, alias name is nothing but here alternative name. Import module name as an alias name. So alias name is nothing but alternate name. So just try to understand this alias name. So alias is nothing but what here alternative name. Alias name is nothing but what here alternative name. Okay. So there is an alias name. Alias name is nothing but alternative name. So import module name as what here alias name. Alias is nothing but alternative. So this syntax allows to import. This syntax allows to import. This syntax allows to import. You can use this particular syntax to import module with another name in current module, another name in current module. The syntax allows to import module with another name in what? Current module, with not with the same name, but with a different name. Big, right? Then you can give some short name that is called as which one? Alias name. For example, you'll say import pandas. Import pandas as some P and PD. You'll say import numpy. Okay, numpy as what here? NP. Okay, I'll say import scientific pi. Okay, scientific pi as what? SP, like this. It means now what is this PD, NP and SP? All these are what? Alias name. If I'm trying to say import Kinter, okay, Kinter as what? TK. Okay, Kinter as TK. Now all these are which names here? Alias names. Alias names are nothing but alternative names. It means I try to access the pandas in my program by using what name? PD. I try to access this numpy by using what name? NP. I try to access scientific pi by using which one? SP. I try to access the Kinter by using which one? TK. I try to access pandas by using what name? PD. I try to access numpy by using NP. I try to access scientific pi by using SP. I try to access a Kinter by using which one? TK. Getting or not? Now, this is alias names. All these are which names here? Alias names. Alias means alternative names. Now, this is useful when multiple modules are with the same name. And this is useful if you want to access the module with another name, then you take the help of this particular syntax. Then you take the help of this particular syntax like PD, NP, SP, and what is that? TK. All these are called alias names. But same thing only, but you are trying to access with what? Alias names. So module 2 is there. In module 2, I'll say module 1 as M1 and module 3 as what? Module 3 as what? M3. So wherever module 1 is there, I have to access it by using which one? M1. M1.x, M1.y, M1 dot function 1, M1 dot function 2, and M3 dot function 4, M3 dot function 5, M3 dot function 5. If I run this, but are you accessing with module 1 or M1? M1. Are you accessing with module 3 or M3? M3. Okay, you are not accessing with the same name, but you are trying to access with what? Another name. And that another name, you call it as which one? Alias name. Then another name is called as an alias name. Alias is nothing but alternative name. So this is an example here in module 3.py. You're accessing with the alias names. So already module 1, module 2. This is in module 2.py. You're accessing module 1 with the alias name as a. You're accessing module 1 with the alias name as what? M1. You're accessing module 3 with the alias name as what? M3. So this is syntax 1 and syntax 2. Syntax 1 and syntax 2, right? Then we'll try to see other syntaxes like syntax 3, 4, 5. And even I'll tell you how to group all these modules within one package. And after that, we'll see exception handling and all other things, right? So today we'll stop it here and Monday we'll continue this, right? Thank you. We'll see you on Monday.